National Electrical Code Section 250.118 states that where a bare or insulated equipment grounding conductor is connected to a coated grounding conductor, the connection shall be made in a manner that will not damage the coating. Section 250.24e states that the equipment grounding conductor shall be permitted to be bare, insulated, or covered. Based on the NEC, connecting a bare ground wire to a coated ground wire is allowed provided that the connection is made properly to prevent damage to the coating. The NEC does not have any specific requirements for healthcare facilities regarding connecting bare and coated ground wires. An electrical contractor who states that it is against code to connect a bare ground wire to a coated ground wire is incorrect. The other contractor is correct in stating that it is permissible according to the NEC. However, it is important to ensure that the connection is made properly to protect the coating on the coated ground wire. This may require using a special connector or other means to prevent damage. To resolve the issue, consider the following. Firstly, have a qualified electrician inspect the existing grounding system to determine the condition of the coated ground wires. Secondly, specify that the connection between the bare and coated ground wires be made in accordance with the NEC requirements. And thirdly, obtain a permit from the local authority to ensure compliance with all applicable electrical codes. Grounding is a critical aspect of electrical safety, ensuring a low impedance path for fault current to return to the source, thereby facilitating the operation of overcurrent protective devices like circuit breakers and fuses. The purpose of the equipment grounding conductor is to provide a safe path for fault current. This path is intended to minimize the voltage potential between metallic equipment enclosures and ground, reducing the risk of electric shock. The NEC provides comprehensive guidelines on how to properly install grounding systems, specifying conductor sizes, connection methods, and bonding requirements. When connecting grounding conductors, it is crucial to use approved connectors and methods that maintain the integrity of the electrical connection and prevent corrosion. The grounding system must be designed and installed in accordance with the NEC to ensure its effectiveness in protecting against electrical hazards. The NEC addresses various grounding configurations, including separately derived systems such as generators and transformers, which require specific grounding methods to ensure proper operation and safety. Grounding electrodes, such as ground rods, ground plates, and metal water pipes, are used to establish a connection to the earth, providing a path for fault current to dissipate. The selection and installation of grounding electrodes must comply with NEC requirements to ensure their effectiveness. Bonding is the process of connecting metallic parts of an electrical system together to create a low impedance path for fault current. Bonding helps to minimize voltage differences between metallic parts, reducing the risk of electric shock. The NEC specifies bonding requirements for various components, including metal conduits, equipment enclosures, and structural steel. Ground fault circuit interrupters, or GFCIs, are designed to protect against electric shock by detecting small imbalances in current flow. GFCIs are required in certain locations, such as bathrooms, kitchens, and outdoor areas, where the risk of electric shock is higher. The proper installation and testing of GFCIs are essential to ensure their effectiveness in preventing electrical injuries. The size of the grounding conductor is determined by the size of the overcurrent protective device protecting the circuit. The NEC provides tables that specify the minimum size of the grounding conductor based on the ampere rating of the overcurrent device. It is important to use the correct size grounding conductor to ensure that it can safely carry fault current. The material of the grounding conductor is typically copper or aluminum. Copper is a better conductor of electricity than aluminum, but aluminum is less expensive. The NEC allows the use of either copper or aluminum for grounding conductors, provided that the conductor is sized appropriately. The connection of grounding conductors must be made using approved connectors and methods. The NEC specifies requirements for grounding conductor connections to ensure that they are mechanically and electrically sound. Improperly made grounding conductor connections can result in high resistance, which can impair the effectiveness of the grounding system. Grounding systems should be inspected and tested regularly to ensure that they are functioning properly. The NEC recommends performing periodic testing of grounding systems to verify their effectiveness. Testing can include measuring ground resistance and performing continuity tests. The NEC provides guidelines for grounding in various types of occupancies, including residential, commercial, and industrial buildings. Each type of occupancy has specific grounding requirements based on the electrical characteristics of the building and the potential hazards present. The NEC addresses grounding requirements for sensitive electronic equipment, such as computers and medical equipment. Sensitive electronic equipment can be susceptible to damage from voltage transients and noise on the grounding system. The NEC provides guidelines for grounding sensitive electronic equipment to minimize these risks. Grounding systems should be designed to minimize the risk of ground loops, which can cause noise and interference in electronic equipment. Ground loops occur when there are multiple paths to ground, which can create circulating currents. The NEC provides guidelines for avoiding ground loops in grounding system design. The NEC addresses grounding requirements for swimming pools and spas. Swimming pools and spas are particularly hazardous environments due to the presence of water and electricity. The NEC provides specific grounding requirements for swimming pools and spas to minimize the risk of electric shock. The NEC addresses grounding requirements for agricultural buildings such as barns and stables. Agricultural buildings can be exposed to corrosive environments and may require special grounding methods. The NEC provides guidelines for grounding agricultural buildings to ensure the safety of livestock and personnel. The NEC addresses grounding requirements for mobile homes and recreational vehicles. Mobile homes and recreational vehicles are subject to movement and vibration, which can affect the integrity of the grounding system. The NEC provides specific grounding requirements for mobile homes and recreational vehicles to ensure their safety. The NEC addresses grounding requirements for hazardous locations, such as areas where flammable liquids or gases are present. Hazardous locations require special grounding methods to prevent explosions and fires. The NEC provides guidelines for grounding hazardous locations to ensure the safety of personnel and equipment. The NEC addresses grounding requirements for high-voltage systems. High-voltage systems require special grounding methods to protect against electrical hazards. The NEC provides guidelines for grounding high-voltage systems to ensure the safety of personnel and equipment. The NEC addresses grounding requirements for direct current or DC systems. DC systems require different grounding methods than alternating current or AC systems. The NEC provides guidelines for grounding DC systems to ensure their safety. The NEC addresses grounding requirements for renewable energy systems, such as solar photovoltaic or PV systems and wind turbines. Renewable energy systems require special grounding methods to protect against electrical hazards. The NEC provides guidelines for grounding renewable energy systems to ensure the safety of personnel and equipment. The NEC addresses grounding requirements for electric vehicles and charging stations. Electric vehicles and charging stations require special grounding methods to protect against electrical hazards. The NEC provides guidelines for grounding electric vehicles and charging stations to ensure the safety of personnel and equipment. The NEC is a constantly evolving document that is updated every 3 years. It is important to stay up to date on the latest changes to the NEC to ensure that electrical installations are in compliance with the code. Continuing education courses and training programs are available to help electricians and other electrical professionals stay up to date on the NEC. Proper grounding is essential for electrical safety. It is important to follow the NEC guidelines when designing and installing grounding systems. When in doubt, consult with a qualified electrician or electrical engineer. Proper grounding protects people from electrical shock, provides a path for fault current, and helps prevent damage to electrical equipment. Grounding is a critical aspect of electrical system design and should not be overlooked. The integrity of the grounding system should be verified during construction and periodically throughout the life of the electrical system. Regular inspections and testing can help identify potential problems before they become serious hazards. Addressing a specific situation, the existing grounding system's age and condition are relevant factors. A healthcare facility built around 1965 might have grounding practices that differ from current NEC requirements. While connecting bare and coated ground wires is generally permissible under the current NEC, the overall grounding system should be evaluated for compliance with modern standards, particularly in a healthcare setting where electrical safety is paramount. The recommendation to have a qualified electrician inspect the existing grounding system is crucial. This inspection should assess the condition of all grounding conductors, connections, and electrodes to ensure that they meet current NEC requirements and are free from corrosion or damage. The inspection should also verify the continuity of the grounding system to ensure that a low impedance path exists for fault current. The requirement to obtain a permit from the local authority is also important. A permit ensures that the electrical work is subject to inspection by qualified electrical inspectors who can verify compliance with the NEC and local electrical codes. The inspector may require specific tests or documentation to demonstrate compliance. The use of special connectors or other means to prevent damage to the coating on the coated ground wire is essential. The NEC requires that connections be made in a manner that does not damage the coating, which means that the connector must be designed to provide a secure and reliable electrical connection without abrading or cutting into the coating. The type of connector used will depend on the size and type of grounding conductors being connected. Some common types of connectors used for grounding conductor connections include compression connectors, set screw connectors, and split bolt connectors. Compression connectors are typically used for larger grounding conductors and provide a high-strength, low-resistance connection. Set screw connectors are typically used for smaller grounding conductors and are easy to install. Split bolt connectors are typically used for connecting two or more grounding conductors together. All connectors used for grounding conductor connections must be listed and labeled for grounding purposes. Listed and labeled connectors have been tested and certified by a recognized testing laboratory to meet specific performance requirements. The NEC also requires that grounding conductor connections be accessible for inspection and testing. This means that the connections must be located in a place where they can be easily accessed without having to remove or disassemble any equipment. The connection should be made in a manner that is mechanically sound and electrically continuous. Avoid creating sharp bends or kinks in the grounding conductors, as this can increase resistance and reduce the effectiveness of the grounding system. In healthcare facilities, electrical safety is of utmost importance due to the presence of sensitive medical equipment and vulnerable patients. Therefore, it is crucial to ensure that the grounding system is properly designed, installed, and maintained. In addition to the NEC requirements, healthcare facilities may also be subject to other standards and regulations related to electrical safety, such as those issued by the National Fire Protection Association, or NFPA, and the Joint Commission. These standards and regulations may require additional grounding measures such as isolated power systems and equipotential grounding to minimize the risk of electric shock. The use of isolated power systems in critical care areas, such as operating rooms and intensive care units, helps to isolate patients from ground faults. Isolated power systems use a special transformer that is designed to limit the amount of current that can flow to ground in the event of a fault. Equipotential grounding involves bonding together all metallic surfaces in a patient care area to minimize voltage differences. This helps to reduce the risk of electric shock by ensuring that all metallic surfaces are at the same potential. Healthcare facilities should have a comprehensive electrical safety program that includes regular inspections, testing, and maintenance of the grounding system. The electrical safety program should also include training for healthcare staff on the proper use of electrical equipment and the hazards of electric shock. The overall goal of the electrical safety program should be to create a safe environment for patients, staff, and visitors. The specific grounding requirements for a healthcare facility will depend on the type of facility, the types of medical equipment used, and the applicable codes and standards. It is important to consult with a qualified electrical engineer or electrical contractor to determine the appropriate grounding requirements for a particular healthcare facility. The NEC provides a comprehensive framework for grounding electrical systems, but it is important to remember that the NEC is not a design manual. The NEC provides minimum requirements for grounding, but but it may be necessary to exceed these requirements in certain situations to ensure adequate electrical safety. Grounding is a complex and technical subject. It is important to have a thorough understanding of the NEC and other applicable codes and standards before designing or installing a grounding system. When in doubt, consult with a qualified electrical engineer or electrical contractor. Proper grounding is essential for electrical safety. It is a critical aspect of electrical system design and should not be overlooked.